My name is Yushu Ni, and I'm going to give an overview of embedded deep learning object detection model for traffic in Asian country competition in ICMR 2021 GC PAIR competition. Here is the outline of my presentation. First, I will introduce the competition. In recent years, object detection in computer vision is more accurate using deep learning method. Relatively, the computation of the algorithm is heavier. If we want to put in the algorithm to embedding system, we have to do some effort on lightening the deep learning model. Because the embedded systems are limited in computing capability and memory consumption. We can see this graph as the deep learning accuracy getting higher recently, from YOLO v3 to YOLO v5. Number of the layers also grow deeper, so as the computational complexity and the GPU computing time. That means higher memory demanding and huge computational costs in the deep learning detection task. Also means more power and area in hardware design, resulting in lower performance. The left graph is observation of Microsoft COCO dataset detection accuracy in object detection task. We are pursuing lower number of operations while keeping the higher accuracy. For example, YOLO v4 or pedal YOLO. And we are moving the implementation platform from high cost and high power GPU to low power embedding system. Here, we can see that the estimated energy consumption of each arithmetic operation and memory access will face the limited bandwidth of the memory in developing deep learning application. And memory access will increase the power and the latency a lot. The next is the introduction of the competition. In this competition, we need to detect 4 types of objects: pedestrian, vehicle, scooter, and bicycle. And we use MediaTek Dimensity 1000 Plus series platform as the embedding system, which is new series of the 5G integrated system on chip designed for flagship smartphones. The goal is to embed object detection algorithm with fast speed and good detection accuracy. Given a test imagery dataset, participants are asked to detect objects belonging to the following 4 classes in each image, including the classes and the bounding box. The qualification competition started on January 4th and ended on March 8th. The qualification competition is 64 days. Final competition started on March 9th and ended on March 26th. Final competition is 18 days. The competition was held by MediaTek Incorporation and Pervasive Artificial Intelligence Research Labs from Ministry of Science and Technology in Taiwan. The dataset and the technology support in the competition is provided by the Intelligent Vision System Lab in National Yangming Jiaotong University in Taiwan, and the Wistron with National Jiaotong University Embedding Artificial Intelligence Research Center. And next, first we will introduce the data information. The data are separated to training dataset and testing dataset. All data imagery resolution are full HD, and the annotation format is XML file, which is similar to the Pascal VOC format. There are 89,000 images in training data. In testing data, 1,000 images are public for validation, 2,700 for qualification competition, and 2,700 for final competition. In the training dataset, we have 736,000 objects. The below table shows the object number of the 4 classes. All the provided data are captured using a dashcam equipped on vehicle driving along the roads in Taiwan, which consists of many cross streets with lots of scooters and vehicles. These capture images including scenes in university campus, urban, rural streets, and highways, with various weather conditions like clear sky, foggy, and raining scenarios. Daytime, night, black lights, and twilight are also included in the lighting condition of these images. It is noted that the provide ground truth labels are only marks on the potential dangerous objects on roads need to be noticed. Scooter and bicycle being parked without drivers will not be labeled. And then introduce the labeling tool. The labeling tool we use is developed by ourselves, which called Easy Label. Its meaning to use to labeling video data. We can label the object property like the type of the car, and also object behavior like turning right, turning left, or overtaking. The main feature of the labeling tool is that it can do semi-auto labeling. The labeler can find the first frame that object appeared in the video, then find the last frame of the object is going to disappear. Finally, press the auto labeling button. All frames between them will be labeled. Competition summary. There are two stages of competition. First stage is qualification competition. All participants submit their answer online. Then score will be calculated. The top 15 teams would be qualified to enter the final rounds of competition. In the final competition, score of the submit design will be evaluated over MediaTek Dimensity 1000 Plus series platform for the final ranking. Then we calculate the ranking score. All the evaluation metrics are linearly distributed with their performance in this matrix. The best is full score, and the worst is 0. The evaluation metrics including accuracy, model size, computation complexity, and inference speed are MediaTek Dimensity 1000 Plus series platform. Accuracy accounts for 14 points. Model size accounts for 15 points. Computation complexity for 15 points. And speed accounts for 13 points. Notice that model size is calculated using number of parameters plotted by bit width. Participants are encouraged to use lower bits representative in their design for better inference speed and model size. We had held 3 competitions: MMSP 2019, ICME 2020, and ICMR 2021, respectively. The registered member grew from 87 to 308. There are total 308 members registered this competition. 85 teams submit their design. The highest performance is 61%. At last, top 15 teams are slated to enter the final competition. Between two competitions of ICME 2020 and ICMR 2021, we can see the performance is higher year by year. Accuracy of first team increased 8%. In the final competition, only 9 teams submit their design. We evaluate the submit image over the MediaTek Dimensity 100 Plus series platform. The final evaluation result is listed. The champions belong to AS 798792 from Computer Science and Information Engineering National University of Tainan, have overall the best model. The first runner-up team is Deep Learner from School of Computer and Information Technology, Beijing 交通部 University. The second runner-up team is
UCBH
from Institute of Computer and Communication Engineering, National Zhengong University. We have other 3 special awards for accuracy. Best accuracy award goes to Team AS 798792. Best bicycle detection award goes to Team AS 798792. And Best scooter detection award goes to Team ABCDA. Model summary. Roughly, Two-stage detector is more accurate, and one-stage detector is faster. For embedding system hardware, one-stage detector is easier to be implemented than two-stage detector. We can see the top 3 teams of 2-year competition is only use one-stage detector. And in ICMR 2021, the top 3 teams all use the same model, YOLO V5. And then is the final evolution highlight. The champion team AS798792. Their model is based on YOLO V5S, structured with DSC CFP-net, with dynamic interpolation, mosaic, and combined IVS dataset and BDD 100,000 dataset. Two-stage training scheme is adapted to elevate the problems caused by data imbalance. And the first runner-up team, Deep Learner. Their model is also based on YOLO V5S and combine multiple datasets as training dataset. Use prediction label of YOLO V5X as the pseudo label to train YOLO V5S. The second runner-up team, UCBH. Their model is YOLO V5 with the CSP-net and combine IVS and Waymo dataset, and also using the data augmentation operation on the mixed images. For 19s who submit the result, they all use one-stage detector, and for the accuracy, adding data and balanced amount of data is the most effective method to reduce the model size and the complexity. They all review the model. In conclusion, the competition embedding deep learning object detection to pursue small model size and low complexity while remain an acceptable accuracy. And we built out a dataset in Taiwan that contains moving objects like vehicles, pedestrians, scooter, and bicycle riders. At last, congratulations to all winners. The champion belongs to AS798792. The first runner-up team is Deep Learner. The second runner-up team is UCBH. We have another 3 special awards for accuracy. Best Accuracy Award goes to Team AS798792. Best Bicycle Detection Award goes to Team AS798792. And the Best Scooter Detection Award goes to the Team ABCDA. This is my presentation. Thank you very much for your attention.